Let's go to Liquor 1368. Minimum cost to make at least one valid pass in a grid. It gives us a multiple by n grid. Each cell has a sign pointing to the next cell, which you should visit. And if you are currently in this cell. So one means go to right, two means go to the left, the three means go to lower, and four means go to upper. So we want to go through zero top left to right bottom, and it the things that for example this one we don't need to change any size. We can go through from the start to end. So we want to change those kind of size as less as we can, right? So want to ask what's the minimal changes we need from the top left to the right bottom. So for example one, right, we need to, if we want to go to the bottom, we can go like this way, right? And change this, this, and this, right? These three. So you to our minimal it returns three. Um, so um, what we're thinking about for this question is that we can use something like a dicaster, but um, for this kind of things is that we want is that the we use a priority queue. Priority queue that is sorted by its cost. The cost is that how many times it's changed for the current cell, right? And we can also have a distance array. So for the distance array, that means for any cell, row, and column, what's the minimal cost we want to use to arrive this cell, right? Um, so for this kind of distance array, we have two options. One is have this kind of distance array, use a two-dimensional array distance equals m multiplied by n, right? Initially, we think about we need to have four multiple by four, right? Means to this cell, we um, still have four directions. Actually, we don't need this kind of the third dimension because we just want to count the when we arrive this cell, we don't consider those kind of directions. What's the least steps we goes to? So we use m multiplied by n as distance array. That should be enough, right? So what we return is that if we have this, if we pull a cell from the priority queue, if we find, for example, those kind of row equals m minus one and column equals m minus one, right? Then we just return the cost. So let's just write code for this, right? So because for this one, it has one, two, three, four as directions, not zero to zero, one, two, three, right? So we can actually have a direction array as put it like this way. Have it final static the int zero. So this is we can add one more, right? So um, the first one, we have one more, the one is going to the right. So for the row, it will not change, right? and 2 is going to the left. It's not changed. And 3, it is going down. And 4 is going up. And the private final static int the column, right? And let's have 0, uh, 1. This is go to right, and this going to the left. And this is going down, this going up. We can also have a distance array, right? So because let's say int m equals grid dot length, and n equals grid 0 dot length. So we are going to have int distance equals new int m multiplied by n, right? Um, so this one we can write for int the in distance. Let's set arrays fill the let's use RIF private final static int equals max right shift to. So we use cost as a sort order for the priority queue. Uh, we call mean heap equals new priority queue um A B. So we use row column and cost. So initially we are at the top left, right? So we are going to have min heap offer new int. So initially those kind of mm, just 0, 0, 0, right? And we're going to have distance 0, 0 equals 0, right? Then what we do is while this kind of queue is not min heap is not empty. Uh, we're going to have int current equals min heap pull. So what we say, if this current 0 equals m minus 1, and the current 1 equals n minus 1, right? Then we just return current 2 as a cost. Um, then what we do is the for the four directions for int k equals 1, k is smaller than 5, k plus plus. We have put one more as because for this one it has direction 1, 2, 3, 4, right? So k is from we iterate 1 to 5. So we're going to have int new row equals current 0 plus d row Okay. And in the new column, it is current one plus D column. Okay, right? In the so the new cost, um, equals so let's determine whether our this kind of direction is equals the sales value, right? So if this grid current zero, um, current one equals K, right? Then we don't need to don't need to because we don't need to use any cost to go to the new row and the new column. So that will be current two. Otherwise, will be current two plus one, right? We need one more cost. So let's check the boundary. If new row smaller than zero or new row greater equal to m or new column smaller than zero or new column greater equal to n. Or the things that if distance array, new row, new column. If we already have this kind of distance smaller equal to the new cost, right? Then we don't need to those kind of move to this kind of cell will not be the optimal. We just continue. Then we're going to have main heap offer new int that is new row, new column, and a new cost. And we'll have distance new row. Because if we go here, that means our distance will always be smaller, right? New cost. So if we didn't meet the line 16, we go out of the uh, while loop, we can return -1. If read, so into new cost, if read there is a brackets here, and this one have one more. So, upper 0, 0. So let's look at and not cost cost two new cost. Mm, current cost. Mm, this is should be greater. line 28, new row, new column. Okay. Um, Also, let's write the Python code for this. So we're going to have d row, d column equals. So we have one more, right? So that is 1, 0, right, left, down, up, and this one will be um right, left, down, up, right? So we have m equals length of width and the length of width 0. So we're going to have distance equals float IF multiplied by and for underscore in range m. Going to have mean heap process. So mean heap that is heap q, right? Heap q dot heap push mean heap there. We need to have the top left and the positive cell, and we have distance. I already set this value as 0. So let's say while this mean heap is not empty, we're going to have we put the first one as the cost. Okay, so we'll have a current cost. It cost and the row and column equals heap q dot heap pop mean heap. Okay. So let's say if row equals m minus 1 and the column equals n minus 1, right? We just return cost. And we're going to for k in range from 1 to 5. New row, new column equals row plus d row k, and column plus d column k. And so the new cost will be cost if grade row column equals k, right? Else that will be cost plus 1, right? So we'll say if new row smaller than 0 or new row greater equal to m or new column smaller than 0 or new column greater equal to n or distance new row new column smaller equal to new cost, right? In this case, we just need to continue. Otherwise, we're going to have heap q dot heap push in heap. So that will be our new cost. new row, new column, and we'll update the distance array, right? Distance, new row, new column equals new cost. And if we jump in out of the while loop, we just return -1. Okay. The time complexity will iterate every cell that's m multiplied by n, but we have a main heap, right? So it will be m multiplied by n log m multiplied by n, right? So the space, the worst case is that every item is in the main heap that is m multiplied by n, right?